From the beautiful studios of Way Happy, this is Mr. Meyer and Chain Rule. So, chain rule is one of those rules that we learned that is going to show up a lot as we do some problems. It's going to be nested inside product rule and stuff like that. So, uh, be a little wary of that it's there and that we got to learn it, and it's kind of fun. So, here we go. The chain rule, I like to think of it a lot of times as the outside inside rule. And that will become clear as you got to think of what the outside function is and what the inside function is. So if you look here, here it is, the chain rule, right? The chain rule says that if you're going to take the derivative of a composite function, then what I need to do is figure out what's the outside function. It's the derivative of the outside function if you leave the inside alone times the derivative of the inside function. So that's a little crazy, but you're kind of treating it like there's this outside function and this inside function, two different things. Let me show you what I mean with this first example. So on this first example, you see I have to take the derivative of sine of 2x. Well, you see that I kind of have an outside function, which I would call the sine of 2x, or the sine of something. And I have the inside function, which is this line, which is just like a 2x. And so that's how you kind of got to think of this. You got to think of this as the outside function because it looks like it's on the outside is sine function, and the inside is 2x. Now, how do you do this? Well, piece of cake now once you get past that part. The derivative of this function would be you take the outside and leave the inside alone. So take the derivative of sine 2x, but leave the inside alone. So what is the derivative of sine? Oh, it's cosine. So we're going to do cosine of 2x. But then we got to multiply it. Chain rule says we got to multiply it by the derivative of the inside function. And what is the derivative of the inside function? It's just 2. And so finally, you multiply those two things together, you get 2 cosine 2x. And there is your derivative. You can kind of see how the outside function was sine. And if you were curious, then the derivative of that would be cosine. And this guy here, the derivative of 2x, the derivative was 2. And so what I kind of did was I took the derivative of the outside, leaving the inside alone, and then I took the derivative of the inside. And that's the chain rule in a nutshell. Here's another one. Look at this one. Find the derivative of this. Well, there's an outside and an inside. Definitely the outside looks like square root, which we don't know how to take a derivative of a square root unless we write it as something that we do know, like an exponent, because that would be much nicer. So I'm going to rewrite this as like this. And you can still see that the square root and the half power, they both look like the outside function, right? So they both look like the outside function. So take that derivative and then multiply it by the derivative of the inside. That's what the chain rule says. So if I try this bad boy, when you have something to the half power, what do? Well, in order to do y prime, I'm going to take the exponent out front. Then you leave that stuff there. And then you power it down by 1. So negative half power. Now, usually that stuff was always just an x. But this time, it's a 3. It's a whole different function. But that's okay. We do it the same way. Chain rule says, hey, ignore the inside. But now I need you to multiply that by the derivative of the inside. And the derivative of that, you're probably pretty good now, is 6x minus 1. And there is our derivative. Now, how are we going to clean this up? Oh, I see a 1 on top, right? And I see a 2 on the bottom. This whole thing's got to move to the bottom. So this is 3x squared minus x minus 1 square rooted, or to the half power. And then it's times this 6x minus 1. Well, that's in the numerator, right? Because it's over 1. So that's going to get multiplied here. So I don't know. How could I clean this up? Oh, please don't do that to me. How could I clean that up? I could make this 6x minus 1 over 2 times 3x squared minus x minus 1 to the half. I guess I could have made that a square root. And I think I'm feeling pretty good. I think I'd be finished there if I wanted to. That's your chain rule. All right, last chain rule example. Let's try this guy. Find the derivative of this. Definitely I can see that the outside function is to the third power. It's like x to the third. So what does that mean? That means I'm going to go the 3 out in front and power it down by 1. And then I'm going to multiply it by the derivative of the inside. So, but I got to leave this alone first, right? Don't touch it. That's the hard part. And then multiply it by the derivative of the inside, which to me looks like 3 minus 4x. And there you have it. Now that is your derivative. Now look, second derivative would be yucky because we'd have to do product rule, right? Have to do product rule for the second derivative. If you want, you could FOIL this all out to make it prettier. But I'll just leave it there for now. And if you're curious, what would I do? I'd square this thing so I'd get 3 terms, and I'd multiply it by that, and then I'd finally multiply it all by 3. That's your chain rule. So remember, outside inside rule, right? Take the derivative of the outside, leave the inside alone, just take the derivative like normal, and then multiply it by the derivative of the inside. All right, have a good weekend. Stay happy. I'll see you tomorrow.